Today we're talking about compound interest. There are two compound interest formulas, and I'll show you which one you'll use depending on the situation. The main one is A equals P times the quantity 1 plus R over N raised to the NT power. Looks kind of complicated, but let's break down what all those things mean because you're just going to plug numbers in for most of those. A stands for the total amount in your account. That would be the principal plus interest. P is principal. Principal means the amount of money you invested at the very beginning. Rate is the interest rate. When you invest your money in a savings account or in some other kind of interest-bearing account, your money will actually grow. They will give you interest over time. N is the number of times it's compounded in a year. They're going to figure out how much interest you've earned and add it into your account. And T is the time in years that you let that money sit there and grow. Another situation that can come up is when interest is being compounded continuously. And when that happens, you change the formula and we're going to use total equals principal times the number E raised to the RT. Notice in this formula, there's no N because it's not, you don't know how many times it's being compounded in a year. It's happening continuously. Nicole invests $7,000 in a savings account with a fixed annual interest rate of 6% that is compounded quarterly. What will the account balance be after 10 years? All right, that is not compounded continuously, it's compounded quarterly, so we're going to use A equals P times the quantity 1 plus R over N, NT, and now we just need to pop in some numbers as we know them. We are asked to find the account balance after a certain amount of time. A is not a number that we know yet, that's going to be the answer. 7,000 is the principal. We know that the rate is 6%, and when you put that into the formula for R, you need to change that to a decimal, 0.06. We know compounded quarterly means that it's going to happen every quarter in the year, which would mean it's happening 4 times. So the N is also 4 in the exponent, and the time that this money is going to sit there is 10 years. Now go ahead and watch as I finish out the math. All right, it's the same example. It's still Nicole, and she's still investing $7,000 in a savings account that is 6% rate compounded quarterly. But now I want to know how long it's going to take in order for her to have $100,000 in the bank. So 100,000 equals 7,000 times. I'm going to cheat a little bit with the maths and just borrow the number we just did this. So it's 1.015, and we're going to raise that to the 4 and the T. Time is the variable we don't know. We do know it's compounded quarterly. Everything is the same. We just don't know how long we need to leave the money in the bank in order to get this certain amount. Let's simplify by dividing by 7,000 first. I like to do a shortcut and just cross off my zeros. So when I do my math, I'm going to do 100 divided by 7, and that's 14.286. And that equals 1.015 raised to the 4t power. And when you have a variable in the exponent, it's called an exponential equation. And if you're not familiar with how to solve those, check out the video I have linked up above, and I'll also put the link in the description. But in order to solve these, you need to use logs. I personally always like to use natural log because it works, and it only has 2 letters, and I'm really lazy. All right, so I'm going to take the natural log on both sides, and so we now have that the natural log of 14.286 equals the natural log of 1.015 raised to the 4t power, and the reason natural log is awesome is because it brings exponents down. So we now have the natural log of 14.286 equals 4t times the natural log of 1.015. Now to divide to solve for t, there are 2 numbers being multiplied by t on the right side. I am going to divide by both of those at the same time. Grab the calculator, do this a little carefully depending on the calculator that you're using. I'm coming up with the time of 44.65 years. She leaves that at $7,000 alone, doesn't make any more deposits. That's how long it's going to take for that thing to grow to $100,000. To keep things as simple as possible, we are still using the same example of Nicole with her $7,000. But now we're changing it up, and she actually is putting it in a different account that has the same rate, 6%, but now it's compounded continuously, which means we're going to use a completely different formula. The question is, how long will it take in this account to reach $100,000? So we'll be able to compare. So the formula we're using is amount equals principal times e raised to the RT. Our amount that we want to have is $100,000 again. Principal is $7,000, and e is being raised to the 0.06t, and we're going to solve this the same way. Using natural logs so that we can bring those exponents down. So the natural log of 14.286 equals 0.06t times the natural log of e. But this is so cool. The natural log of e equals 1. So whenever you see that, you can kind of ignore it because it's just like multiplying times a 1. I'm going to divide right now by 0.06. And now we have the answer is 44.32 years. Now, if you want to compare that, that's faster than the other one, but not by a lot. Let's see how much. Well, I mean, she would get to her goal of $100,000 4 months faster. I mean, that's cool. Can't lie, though. I was kind of hoping it would be like years faster, but still. This is a different type of problem. In this one, I want to know, what is the interest rate paying? If she got to $9,688.21 after 10 years in an account that was compounding continuously, what was the rate? So again, it's compounded continuously, so we're using PERT. Yeah, I named this one PERT. It's my favorite compound interest formula. All right, 9,688.21 equals 7,000 times E raised to the R times 10, because we don't know the rate and we do know that it's going to sit there for 10 years. Start by isolating E, because E has the variable in the exponent. Divide both sides by 7,000. 1.38403 equals e to the 10r. Now, to get that variable out of the exponent, to get it to drop down, we need to use natural log on both sides. Natural log of 1.38403 equals 10r times the natural log of e, and yay, natural log of e equals 1, so we can ignore that. Divide both sides by 10. And we get R equals 0.0325, which is a rate. But if you want to know the percent, like what it's going to be advertised as, you need to move the decimal place 2 places, and the rate is 3.25%. In this problem, she's investing a sum of money in a retirement account with a fixed annual interest rate of 5% compounded continuously. After 20 years, the balance reaches $15,026.66. And the question is what was the amount of the initial investment? And this time the variable is P. That's the thing we don't know, is the principal. So $15,026.66 equals P times E raised to the rate, which is 0.05, and the time is 20 years. When you multiply 0.05 times 20, you get a 1, which makes this problem kind of interesting. Most of the time, I don't think that's going to happen when you're doing your problems, but I included this because that could be confusing just because it's really simple. So I wanted you to see what to do with that. So we now have to divide both sides by E in order to solve for the principal, and that's $5,528. Hey, if you got some value out of this, it would help me out a lot if you would like and subscribe so this channel can grow on YouTube. Thank you.